Okay guys, so we're starting on page 9 of your unit packet, and I'm going to talk you through the 2 new rules that you're going to be responsible for internalizing today and using on your problem set. So you can see at the top of the page 9, the first rule that we're going to be utilizing today is called the product rule. Snipped straight from a textbook, the definition of the product rule is listed for us here. For a function which has been written as the product of 2 functions, say y equals f of x times g of x, the derivative can be found using y prime equals f prime of x times g of x plus f of x times g prime. The way that I say this is in quotes right here. To find the derivative of a product, we will take the derivative of the first times the second plus the first times the derivative of the second. An example here, I'm going to show in 2 ways. The function that's provided for us is y equals x squared minus 3x times x. This could very easily be something I gave you yesterday, and we would have described this as not being ready yet for the power rule, because I don't just have a string of sums and differences. I've got this multiplication that throws a wrench in my ability to use the product rule. So according to yesterday's work, what I would have to do here is first clean this up algebraically through, in this case, probably distribution, resulting in a simplified function of x cubed minus 3x squared. After that algebraic manipulation, we would say this is now ready for y prime. So I would use my power rule and get a function for my derivative that is equal to 3x squared minus 6x. There's absolutely nothing wrong with that strategy, but now if we know the product rule, we could do this problem in a different way without requiring the algebraic manipulation at the beginning. So I'm going to rewrite the function, and instead of immediately doing some distribution, I'm going to annotate that first term of my product as f and the second as g, so that this lines up nicely with the definition of the product rule up here. It turns out if I use the product rule on this, my y prime can be found a little bit simpler by simply following this narrative up here that I annotated. I need to find the derivative of the first. So I look at the first function down here, and the derivative of that, I think we can agree, is 2x minus 3. I'll multiply that by the second function, which is x. I then add the first, so no derivative, just the actual first function, times the derivative of the second. And we remember that the derivative of x is just 1. Again, for my annotators, since this is the first time you're seeing this, what I've done here is found f prime, multiplied that by g, added f times g prime, which is the definition of the product rule. From here, of course, because you know I want simplified answers, I would have to do a little bit of algebra, and I would see here that y prime is equal to 2x squared minus 3x plus x squared minus 3x. Combining like terms, I get y prime equals 3x squared minus 6x. Kind of cool. We get the same result. Sometimes I'll ask you to do algebraic manipulation first. You would come over here to the first strategy. Other times I'll require you to use a product rule. You would use a second strategy. Most of the time it's your preference and it's what comes most naturally to you. There are some instances where one strategy is definitely a time saver and the other one is a time suck. The more you do, the more equipped you'll be to identify those situations. So the other rule that is new material for today is called the quotient rule. Naturally, if we learn a rule for products of functions, there is of course going to be a rule for quotients of functions. So when we see a function provided to us in the form of f over g, we see that division, we can find the derivative using what's called the quotient rule. This one's a little bit more intense. G of x times f prime minus f of x times g prime over g of x squared is what our derivative would be equal to if we have a quotient like this one. The cutesy way of saying this is kind of coming up here to the original function and labeling the function on the bottom as our low function and labeling the function on the top as our high function, high and low. And then this cutesy little saying kind of works out. To find our derivative, we'll do low d high minus high d low all over low squared. And this d notation right here means the derivative. So we'll take the low function times the derivative of the high function minus the high function times the derivative of the low all over low squared. So we'll say that a lot and it'll get more ingrained in your mind, but for right now we have like the formula there at the top to ground us in this. So as an example, here's a function that's definitely a quotient, x squared minus 3x all over x. And if I utilize old strategies from yesterday, I would have to split this then into two separate fractions and simplify. X squared over x is x, 3x over x is 3. I could then find y prime, which in this silly case turns out to just be 1. Cool, nothing wrong with doing that. The new way of doing things requires no algebraic simplification. Instead, we kind of either in our head or on our paper identify what's on top as the high function. That sounds silly. And what's on bottom as the low function. And then we can apply our rule. The rule says that the derivative is equal to low, exactly what I see on the bottom, x, times d high, derivative of the high function, or the one on top, 2x minus 3, minus high, the function on the top, exactly as it is, d low, times 1, all over low squared. When I do some math here, in particular a distribution on this first term, I get 2x squared minus 3x. I distribute here the negative sign. I get a minus x squared plus 3x all over x squared. Some cool stuff happens. You can probably see it. 3x's are gone. So this becomes 2x squared minus x squared. That's just x squared. I've got an x squared on the bottom. What do you know? My answer is 1. Smiley face, because those are the same. Again, as I mentioned on the product rule, sometimes I'll specify which strategy you're supposed to use. Other times it's a matter of your intuition in terms of what you recognize to do quickly. I will say oftentimes when students learn the quotient rule, they immediately gravitate toward using this, and that is not necessarily always the easiest thing to do. If you can ground yourself in algebra, I would highly suggest trying to attempt something algebraically first. You'll notice the steps here were much simpler than they were over here, and I didn't have to remember an intense formula. I just had to ground myself in some algebraic manipulation. So that's a suggestion if you want to use it. This video is coming to an end now, and I would urge you to watch a couple of the model problems, at least one. When you feel like you are ready, you can put your phones away and begin working on your assigned problems from problem set 1. But I would definitely get in a couple more models under your belt, some quick, probably 4 or 5 minute videos to get you some more exposure to what these things are going to require of you in the future. Cool.